Hey y'all, Miss Harper here for our simplifying radicals notes. All right, so here is where we are going to start. Right here, we're going to start with a 1. 1 squared, 2 squared, and go ahead and keep filling that out. I'll meet you on the other side of that. Alright, if you're catching back up with me, hopefully you got those filled out. So this is the way that we find what we call our perfect squares, a number times itself. So if you need a little helpful reminder, 1 squared means 1 times 1, 2 squared means 2 times 2, 3 squared means 3 times 3, and that's how we obtain what we call a perfect square, a number multiplied by itself. So 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9. And we can continue filling that out. Oops. That's better. 100, 121, 144, and 169. All right. So this is what we call our perfect square. So it's not that you have to memorize or you don't have to memorize your perfect squares, but you should know how to find your perfect squares. And the way you do that is, again, by just making your list and multiplying that number by itself, and you can write out your list of perfect squares. Now obviously this goes beyond 13, but if you can get the first 13 wrapped up around your head, then that's a really good place to start. After we have found our perfect squares, now we want to talk about the square root of these numbers. So this is our square root symbol. Alright, and we're talking about the square root of the perfect square. So the square root of 1 is 1. The square root of 4 is 2. Now notice how I'm not saying 1 squared or the square root of 1. I'm just saying 1 or 2. Alright, it's just the whole number. So the square root of 9 is 3. The square root of 16 is 4. And then we can keep going down our list that way. And again, just to reiterate, it is the whole number. If you have a highlighter, I would pause real quick and highlight your perfect squares, those middle numbers, just like I did on here on the notes. All right, our first step in simplifying our radicals is, first step is to find the largest, keyword, perfect square factor of given number. Okay, and this will make a little bit more sense in a second. Once I have found the largest perfect square factor, I'm going to list out my factor pairs. And then my third step is going to be simplify the perfect square. All right, so again, it's important that we find the largest perfect square. So as we're finding the perfect squares, we're going to want to work backwards down this list right here. All right, so that's the direction you want to work through. All right, we talked about factor pairs whenever we were learning how to factor. So that's a number multiplied by some other number that equals a number. So for example, factor pairs of 5 would be 1 times 5. All right, well this time it's important that one of our factor pairs is one of these perfect squares from our highlighted row right here. Let me try to explain to you real quick what we're doing. This is just a little side note. I'm going to go up here by our little radical man. So for example, whenever you're learning how to reduce fractions, you would find a common factor and then you would simplify it. So for example, a common factor of 3 and 6 would be 3. So I would divide the top by 3 and that would be 1. Divide the bottom by 3 and that would be 2. Now these things are equivalent. If I typed it in the calculator, they would both be 0.5. We're kind of doing the same process here with our radicals. We're given a radical, but we can simplify him further, just as we were given a fraction here, but we could simplify him further. That's the comparison I choose to make. So let's try out our first example. All right, the square root of 20. All right, so first step, find the largest perfect square factor of the given number. So I'm going to work backwards down my line here, and I'm going to find what's the largest perfect square factor that divides nicely into 20. All right, well, obviously 36 doesn't divide nicely into there. 25 doesn't either. If you're unsure, you can just plug them into your calculator. So obviously it's going to be a number smaller than 20, so I'm going to start with 16 in case you're unsure. 20 divided by 16. Now I get a decimal, so that means he's not a factor of 20. So then I go to the next number, 9. 20 divided by 9. Again, I get a decimal, so he's not a factor. 20 divided by 4. And ding, 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 I have just found my largest perfect square factor. So I can say that the square root of 4 times the square root of 5 is equal to the square root of 20. So just like regular 4 times regular 5 is regular 20, I can say the square root of 4 times the square root of 5 is the square root of 20. Alright, so now I found the largest perfect square. I listed out my factor pairs. This was our step 2. And now my step 3 says to simplify the perfect square. Well, what is the square root of 4? It is whole number 2. So we call this 2 square root 5, or 2 root 5, and that is our final answer. Alright, just like with the fractions I was talking about earlier, we can make sure that these things are equal. It's a great way to check to make sure you did your steps correctly. So that's what the square root of 20 is. It's not a perfect square. He's some long, long, long decimal. So now that I've simplified him, I want to make sure that these two things are still equivalent. It's just a simplified version of the radical, hence simplifying radicals. Alright, so there we go. I know I'm good to go there. Next, let's look at the example square root of 51. Alright, so again, work down your list. Okay, I want to do 51 divided by, okay, probably not 49, probably not 36, but maybe 25 if you're not sure. Alright, it's not that one, so I'm going to go down to the next number. I'm going to try 16. Doesn't work. 51 divided by 9. Nope. 51 divided by 4. Nope. 51 divided by 1. Well, obviously 1 is going to work because 1 works with everything. So my example I'm going to say to the side over here, it's like getting a fraction 3 over 5 and asking to simplify this fraction. Well, I can't reduce him any further. Their only common factor between 3 and 5 is a 1. So therefore 3/5 is as simple as he's going to be. The same thing applies here for the square root of 51. If 1 is the only perfect square factor, then his number is just going to stay as the square root of 51. He is in his most simplified form already. Alright, so go ahead and pause the note video here, and I want you to try out these 4 practice problems, and then you can come back and see how you did. Ready, set, go. Alright, if you're joining me again, check and see how you did. Alright, some common mistakes I often see. Let's see. First, you should always list your perfect square factor first. It just makes it an easier process. It would be weird if you wrote it as the square root of 2 times 3. It's kind of like saying x2 instead of 2x, so just don't do that. Alright, so 3 times the square root of 2. Next, I went to the square root of 13. Well, the only factors of 13 are 1 and 13, so therefore 13 was already in his most simplified form. Alright, with the square root of 150, again, work backwards down your line. And the first number that divided nicely into 150 was 25. So I have the square root of 25 times the square root of 6, and the square root of 25 simplifies to 5, and we're left over with 5 root 6. And then our fourth one, I might have tricked you here, but if you're looking down your line and you're like, okay, where am I going to start? Oh wait, 36. 36 is a perfect square. So the square root of 36 is just 6. Alright, he is a perfect square, and sometimes you just see those in there. Alright, so that's it for simplifying radicals. Go ahead, if you have any questions, go see your teacher, and you should have a practice assignment, a little matching assignment to go on from here. Good luck.